Almant's technology and their solar cat eye system is a break-even scenario, but this particular set of questions is actually a good example of a very certain kind of problem in which the official formula can actually be more trouble than it's worth. I'll show you what I mean in a moment. Almant's technology sells the solar cat eye system, which generates electrical power from solar cells built in bright reflective lenses embedded in the surface of roadways that mark travel lanes. Okay, that's nice. And they're referred to as cat eyes because they reflect headlights during the night, allowing drivers to see the borders of the lane when it's too dark to see the painted stripes. Got it. When the solar cat eye system is installed in the surface of a road, it allows the road to generate power that can charge batteries for nearby road signs, emergency phones, or signal lights, saving the cost of electricity that could otherwise have been purchased to operate those systems. Now here we get down to some actual data. A solar cat eye installation costs $100,000 to set up the operating system, plus $2,000 per mile installed directly into the road. Now, I'm going to note this to the side. That's a definite fixed cost, the $100,000. Although, wait a minute, and that's something that's a little sneaky about this problem, plus $2,000 per mile looks like it's suggesting a variable cost, but it's per mile of road and it's still installation. So I'm just going to mark that with a question mark for now. Each mile of solar cat eye creates the equivalent of $200 a year in revenue. Okay. That's good to know. With no variable cost of generation. Oh, all right. And now, something that's a little sneaky about this problem. It looks here, the $2,000 per mile, as if that's some type of variable cost. But we're talking about installing a system and then using it year by year by year. And it's saying that the revenue, 1 year of production, the revenue is $200, right, per mile. Now wait, you might be thinking this needs to fit into the break-even formula. Well, first off, actually, I'm skipping ahead a bit. Part A is just simple analysis. It's just common sense. Maricopa is considering purchasing a solar cat eye installation for 100 miles of road. How much would this cost? We just want to tally that based on what we were told. That's no particular formula. Let's see. They would need to spend $100,000 on the operating system. I mean, that's what we were told up here. Plus, the size of the system, 100 miles of road times the $2,000 per mile. Then how much would the system cost? There's no other costs. Oh, okay. So, this is the actual installation of the cat eyes. Right, that's what was referred to here. What this winds up being is it's mostly the per mile installation. It winds up being 100,000 plus 200,000. The answer is 300,000. Note that the bulk of the cost of the system that's been proposed here for Maricopa County, right, just the 100 miles, is actually that $2,000 per mile installation of the cat eyes. All right, now that's no particular formula. We're just using some of the data we're given. What looks like a break-even problem is part B. If Maricopa County does purchase the solar cat eye system for its summer repaving project, how many years of electrical generation must it provide before it breaks even? You say, how could that not be a break-even problem? I'm going to need the formula, the fixed cost, revenue minus variable cost. Well, yes, actually, you can use this formula. Notice what you were asked. How many years? Remember, break even is an amount like production, and it works in this case. But this is another case where maybe it would just be easier to reason through this with logic than to revert to that formula, because you're asked how many years will it take for this installation to pay off? Well, Maricopa County has to spend from Part A $300,000, right? And then what are we told about it? Let's see. It will produce $200 per mile, and there'll be 100 miles doing that. That's essentially the revenue. That's $20,000 a year in revenue, minus, well, there's no variable cost here of electrical generation. It said that in the scenario. Now, this is the formula, but it's easier to picture $300,000 to buy it. Little bit of side calculation here. It will generate $20,000 a year worth of electricity. All right, so if I divide the $20,000 into the $300,000, that's going to reveal how many years it will take for it to break even or to pay for itself. So that is where we get the answer. Whoops, it's going to take a while. Even at $20,000 a year worth of electricity, it's going to take it 15 years to pay off. Oh, all right. Now, but anyway, that's the answer to the question. Now, some officials in Maricopa County have argued that this summer's repaving project's too small, you know, like the 100 miles of lane, to support a technology upgrade such as the solar cat-eye system. However, the state highway department might be convinced to share the $100,000 fixed cost. Now that's the cost of the operating system with Maricopa County if it can share the same operating system, right? It will then purchase solar cat-eyes and install them in a nearby state highway if the two organizations can reach an agreement to share the fixed cost equally. How will this change Maricopa County's break-even point? Well, the key to answering that question is to just focus on what part of the previous calculations, let me cheat this back up here, has changed, right? Okay, there's this business about the state highway department might go in on the operating system. Okay, and if they share it equally, the cost of the operating system, you recall, was $100,000. And they're proposing to share it equally. So that means that if the state highway department cooperates, the new cost, maybe I could write that, new cost of operating system is half what it used to be. Oh, they could get, essentially, by sharing, they could get the operating system for $50,000. Oh, all right. Now, what did that do to the overall cost of the system? They still have to install their, and we're talking about Maricopa County, they still have to install their 100 miles of cat-eyes, so it's $50,000 plus $200,000. The overall purchase price of their system sinks from $300,000, what it was in Part B, to $250,000. The denominator is the same. We still have that same. It's $20,000 a year in revenue generated, 200 times 100. You still have that zero variable cost. That reveals that if the state highway department will split the cost of the operating system, Maricopa County's solar cat-eye system will pay itself off in 12 and a half years. Or so, oh, interesting. So if they share the operating system with the state highway department, then they go from it taking 15 years for this project to pay itself off to it taking 12.5 years for the project to pay itself off, or only 2.5 years. Now, whether or not they should do that, the savings of only 2.5 years. If they should do that really depends on what are the other costs with potentially having to cooperate with the state highway department. But at any rate, the answer is 12.5 years.